Picture this. A mountain range rising so slowly you'd never notice it in a lifetime, yet it's powerful enough to reshape entire continents. Or a coastline slipping away, inch by inch, over centuries, swallowing towns without a single dramatic wave. These aren't the Hollywood-style disasters we're used to. No roaring tsunamis or earth-shattering quakes. These are Earth's creeping cataclysms, the silent, relentless forces that sculpt our planet on a time scale so vast it makes human history look like a fleeting moment. Buckle up, because we're diving into the slow-motion chaos that's been shaping our world for millions of years, and will keep doing so long after we're gone. When you think of natural disasters, your mind probably jumps to volcanoes spewing molten lava, earthquakes splitting the ground, or hurricanes tearing through cities. Those are loud, fast, and in your face. But what if I told you the most powerful forces on Earth are the ones you can't even see moving? These creeping geological disasters unfold over decades, centuries, or even millennia, so subtle they slip under the radar of human perception. Yet their impact is undeniable. Mountains rise, valleys sink, and entire landscapes transform, all driven by processes that don't care about your weekend plans or even your great-grandkids' future. These slow-motion events are a testament to Earth's patient, unyielding power. They're the planet's secret sculptors, working on a geological clock that ticks in eons, not seconds. From the grinding creep of tectonic plates to the silent erosion of coastlines, these processes are reshaping our world right now, just too slowly for us to notice in our daily hustle. Let's pull back the curtain and meet some of these unsung architects of Earth's surface. You've probably heard about plate tectonics, the idea that Earth's crust is broken into massive plates that float on a semi-molten layer below. These plates move, but not in the dramatic earthquake-inducing lurches we usually think of. Most of the time, they creep along at about the speed your fingernails grow, 1 to 10 centimeters per year. Doesn't sound like much, right? But over millions of years, that slow grind has built mountain ranges, opened oceans, and reshaped continents. Take the Himalayas, for example. They're the poster child for creeping cataclysms. About 50 million years ago, the Indian plate started nudging into the Eurasian plate at a glacial pace. That collision is still happening, pushing the Himalayas upward by about 5 millimeters a year. That's slower than a snail, but it's enough to make Everest a little taller each century. The catch? This slow uplift doesn't just create stunning peaks. It triggers landslides, alters river systems, and shifts entire ecosystems. Villages in the Himalayas face constant threats from rockfalls and glacial floods, all tied to this relentless tectonic creep. It's not a one-day disaster, it's a millennium-long saga. Or consider the San Andreas Fault in California. Most of us associate it with the big one, a massive earthquake that could rock the West Coast. But between those rare jolts, the fault is quietly slipping, sometimes without any shaking at all. This aseismic creep moves parts of the fault a few centimeters a year, enough to twist roads, crack pipelines, and stress infrastructure over decades. It's like a slow-motion earthquake that never makes the news but still reshapes the landscape bit by bit. Now let's shift to the edges of the continents, where the ocean is waging a slow, relentless war against the land. Coastal erosion doesn't grab headlines like a tsunami, but it's a creeping disaster that's swallowing shorelines worldwide. Waves, tides, and currents nibble away at cliffs and beaches, sometimes at rates as slow as a few millimeters per year, sometimes a meter or more. It's not dramatic, but give it a century, and entire towns can vanish. Take Happisburgh, a village on England's Norfolk coast. Over the past few decades, the sea has claimed homes, roads, and even a medieval church, all because the soft cliffs erode at about 1 meter per year. Residents watch their properties inch closer to the edge, knowing the sea will eventually win. It's not a sudden catastrophe, but a slow, heartbreaking loss. Globally, rising sea levels, creeping upward at about 3.7 millimeters per year due to climate change, are supercharging this process, turning manageable erosion into a looming threat for coastal communities. What's wild is how this slow theft compounds over time. A beach that loses just 10 centimeters a year might seem fine in your lifetime, but in 500 years, that's 50 meters of land gone. Add in human activity, like building seawalls that redirect wave energy and accelerate erosion elsewhere, and you've got a recipe for a creeping disaster that's as much our fault as nature's. Ever heard of a city sinking under its own weight? That's subsidence, another sneaky geological process that's less about dramatic collapse and more about a slow, steady descent. Subsidence happens when the ground compacts or sinks, often because humans are pumping out groundwater, oil, or gas faster than nature can replenish it. It's like deflating a mattress, except the mattress is the land you live on. Jakarta, Indonesia, is a textbook case. Parts of the city are sinking at rates of up to 25 centimeters a year, largely because of excessive groundwater extraction to supply its 10 million residents. By 2050, experts estimate a third of Jakarta could be underwater, not just from rising seas, but from the ground itself dropping. Imagine waking up each year to find your street a little closer to sea level. It's not a sudden flood, but a creeping nightmare that forces entire communities to rethink their future. Subsidence isn't just a tropical problem. In California's Central Valley, decades of groundwater pumping for agriculture have caused the land to sink by as much as 9 meters in some areas since the 1920s. That's enough to mess with irrigation canals, crack roads, and tilt buildings, all without a single headline-grabbing event. It's a disaster that unfolds so slowly, most people don't even notice until the damage is done. Up in the colder corners of the world, glaciers and permafrost are putting on their own slow-motion show. Glaciers, those massive rivers of ice, creep downhill at speeds ranging from a few centimeters to a few meters per day. It's not exactly Usain Bolt territory, but over centuries their grinding movement carves valleys, reshapes mountains, and leaves behind landscapes that look like they've been sculpted by a giant. The problem? Climate change is speeding up the retreat of glaciers, which sounds fast but is still a decades-long process. As glaciers shrink, they destabilize slopes, trigger landslides, and alter water supplies for millions who depend on their meltwater. In the Alps, for instance, retreating glaciers are exposing loose sediment that can slide downhill, threatening villages below. It's a disaster that unfolds over generations, but its impacts are already being felt. Then there's permafrost, frozen soil that covers about a quarter of the northern hemisphere's land. As global temperatures rise, permafrost is thawing at rates of a few centimeters per year. That might not sound like much, but when the ground you've built your house, road, or pipeline on starts to melt, things get messy. In places like Siberia and Alaska, thawing permafrost is buckling roads, tilting buildings, and releasing methane, a potent greenhouse gas that makes the problem even worse. It's a feedback loop that's been creeping along for decades, but could reshape entire regions in the coming centuries. Let's talk about another slow disaster that's less about rocks and more about life itself: desertification. This is when fertile land turns into desert, often because of climate change, deforestation, or overgrazing. It's not a sand dune swallowing a city overnight. It's a gradual loss of soil, fertility, water, and vegetation that can take decades to fully unfold. The Sahel region of Africa, just south of the Sahara, is ground zero for this creeping cataclysm. Over the past century, overgrazing and erratic rainfall have turned once productive land into barren expanses. The process is slow, maybe a few meters of fertile soil lost per year, but the consequences are brutal. Communities lose their ability to grow food, leading to famine, migration, and conflict. By some estimates, desertification threatens the livelihoods of over 1 billion people globally, all because of a process that's too gradual to make the evening news. What's scary is how desertification feeds into other slow disasters. Degraded land means less vegetation to hold soil in place, accelerating erosion. It also messes with local climates, making rainfall even less reliable. It's a vicious cycle that unfolds over generations, turning thriving landscapes into wastelands. So why should we care about disasters that move slower than a sloth? Because their impacts are massive, cumulative, and often irreversible. A single earthquake might kill thousands in a day, but a creeping cataclysm like subsidence or desertification can displace millions over decades. These processes don't just reshape landscapes, they disrupt economies, force migrations, and challenge our ability to adapt. The kicker? We're often making these slow disasters worse. Pumping groundwater, cutting forests, and burning fossil fuels are like pressing the accelerator on Earth's natural processes. Coastal erosion gets a boost from rising seas. Subsidence speeds up when we overdraw aquifers. Desertification spreads faster when we overwork the land. These aren't just natural phenomena, they're human-amplified crises that unfold so slowly we barely notice until it's too late. Here's the thing. We can't stop Earth's creeping cataclysms. Tectonic plates will keep grinding, coasts will keep eroding, and glaciers will keep creeping or melting. But we can get smarter about living with them. That means building infrastructure that can handle subsidence, protecting coastlines with natural barriers like mangroves, and managing land use to slow desertification. It also means thinking long-term, not just about next year's budget, but about the world our descendants will inherit. Scientists are already on the case, using satellites to track tectonic creep, drones to monitor eroding coasts, and models to predict permafrost thaw. But it's not just about tech, it's about changing how we think. We're wired for instant gratification and immediate threats, so wrapping our heads around disasters that span centuries is tough. Yet that's exactly what we need to do if we want to thrive on a planet that's always, slowly, remaking itself. There's something almost poetic about these creeping cataclysms. They remind us that Earth is alive, constantly shifting and reshaping itself in ways we can barely perceive. The same forces that build mountains over millions of years can destroy a village in a few decades. It's humbling, isn't it? We like to think we're in control, but Earth's slow-motion disasters show us who's really calling the shots. So next time you're hiking in the mountains or strolling along a beach, take a moment to appreciate the silent forces at work. That cliff you're standing on might be crumbling at a snail's pace. That valley might be sinking, millimeter by millimeter. These creeping cataclysms are Earth's way of reminding us that change is constant, even if it takes 1,000 years to notice.